We're talking about gravity today. It's everywhere, right? Like it's holding us down, keeps the Earth spinning around the sun, and it's even the reason why stars can actually exist.
Yeah, you don't really think about it much. I mean, it's just always there.
Exactly. But what if it wasn't? Like, what if gravity just decided to take a break or something?
Or, like, what if it suddenly became way stronger? Or even weaker? I mean, have you ever thought about that?
It's a pretty wild thought. And actually, a lot of our listeners have been sending us stuff about this very idea. So we're diving deep today into all the crazy things that could happen if gravity decided to act a little different.
Yeah, and the stuff you sent me, it starts off with, like, what would happen to us personally if gravity just disappeared? Poof, gone.
Like if it just blinked out for a second.
For a single second, yeah.
According to Brightside, which is one of the things we looked at, if gravity decided to just let you go for a second, you wouldn't really go flying off into space.
No, it's not like that. They say you'd probably just float up a little bit, like maybe an inch or so.
It's almost like you just bounce a little.
Right, and then gravity would come right back and pull you back down.
It's kind of fun, actually.
Yeah, in that scenario it does. But then, they get into what would happen if gravity just stopped working for everything, everywhere.
Okay, now that's not going to be so fun.
Not at all. Everything that's not bolted down would just start floating.
So, like, my coffee cup,
Yep.
the couch,
Uh-huh.
this microphone.
Pretty much everything. And then when gravity comes back, everything just crashes down.
Talk about a mess.
A huge mess. But it actually gets even weirder than that.
Weirder than everything just floating around for a second. How is that possible?
So think about it. Gravity isn't just holding us down to the planet, it's also what keeps all those tiny little atoms inside us together.
Oh, wow. I never thought about it like that.
So if gravity just switched off, even for a second, there's a chance that we might just, disintegrate.
Like, just completely fall apart.
Basically, poof, we just turn into a cloud of atoms.
Okay, that's definitely not good.
Yeah.
But even if we somehow manage to stay in one piece, there's more bad news.
Right, like our blood circulation.
Yeah, it uses gravity to help it flow through our bodies.
Exactly, and our heart relies on that. So without gravity, our blood wouldn't be getting where it needs to go.
And then there's breathing.
Right, that's completely dependent on gravity too. Without it, our lungs wouldn't be able to work properly.
So no gravity, even for a second, is a really, really bad idea.
Seriously bad.
Okay, so let's say that somehow we survive all of that. What about the Earth itself? We know it's spinning pretty fast, right?
Yeah, and that's where inertia comes in.
Inertia. Like an object wants to keep moving in the same direction unless something stops it.
Exactly. Right now, gravity is what's keeping us moving in a circle along with the Earth. If gravity disappeared, we'd all just keep going in a straight line.
So we'd basically be flung off the planet.
Pretty much. Imagine everything on the surface, trees, buildings, even mountains just flying off at hundreds of miles per hour.
It's like a scene from a disaster movie.
More like a planetary demolition derby. And it wouldn't just be things on the surface. The source we looked at talks about how the Earth's core is super hot and under immense pressure. Gravity is what keeps that all contained.
Oh, right.
If you take away gravity, all that molten stuff would just erupt out. It would be like volcanoes everywhere.
A global eruption.
Exactly. And that's not even considering the massive earthquakes that would happen at the same time.
It sounds like the Earth would basically turn inside out.
Pretty much. And even if gravity came back after a second, the damage would be irreversible. Our atmosphere would start leaking into space, and it would take millions of years for things to even begin to recover.
It's incredible to think about how much we rely on this one force that we never even see. But let's zoom out even further. What about the rest of the solar system? What would happen to the sun without gravity?
The sun's a huge ball of burning gas, and it's constantly trying to explode outward. Gravity is what keeps it all together.
So without gravity?
Boom. The sun would basically detonate.
That's not good for us here on Earth.
No, not at all. And it wouldn't just be Earth. Mercury and Venus would be gone too. Mars might even get caught in the blast.
So we're talking about the end of the inner solar system.
At least. And the effects would go even further than that. Really massive stars, the ones much bigger than our sun, they could actually just disintegrate without gravity.
They just fall apart.
Yeah, into dust and gas, and those pieces would fly off at incredible speeds, causing all sorts of chaos throughout the galaxy.
So a 1-second gravity holiday turns out to be a really, really bad idea for the whole universe.
Yeah, not exactly the relaxing break we might have imagined.
But okay, let's change things up a bit.
Yeah.
What if, instead of disappearing completely, gravity just got weaker? Like, what if it was cut in half?
That's actually one of the scenarios that Brightside talks about, and it's a bit less apocalyptic.
Less apocalyptic is good.
Right. So the first thing you'd notice is that you'd feel much lighter.
Like I can finally dunk a basketball.
Probably. You'd be able to jump higher, run faster. Everything would just feel less heavy.
Sounds kind of fun.
Right. Yeah. The source makes it sound pretty exhilarating. But there would be some downsides, too. Like the air would get a lot thinner.
What, like we'd be at the top of Mount Everest all the time?
Kind of, yeah. It would be like living at a really high altitude. Breathing would become more difficult.
Oh, man. Altitude sickness is not fun.
No, it's not. But the source suggests we'd adapt. Maybe we'd learn to breathe differently, take things slower.
And maybe over time, we'd evolve to have bigger lungs.
Yeah, our bodies might adjust to the thinner air over generations. And in the meantime, we'd probably have to use oxygen masks or something.
Makes sense. What else would change with weaker gravity?
Well, our atmosphere would get a lot bigger because gravity wouldn't be holding it in as tightly.
So, like, it would extend further out into space.
Exactly. That would mean more meteor showers, and satellites wouldn't last very long because they'd burn up in the atmosphere.
Not great for our space technology.
No, definitely not. And the moon would start drifting away from Earth.
Really? Why would that happen?
Because Earth's gravity wouldn't be holding on to it as strongly. Eventually, it might even escape Earth's orbit altogether.
So, no more moonlit nights.
Maybe not. And no more tides either. The moon's gravity is what causes the tides, so without it, the oceans would be a lot calmer.
A world without tides. That's kind of hard to imagine.
Yeah, it would definitely change things. But on the plus side, it would be way easier to swim in the ocean.
Oh, yeah, I guess you'd just float around.
Exactly. And imagine the splashes, they'd be huge and slow motion, like something out of a movie.
So, weaker gravity might not be all bad.
No, there would be some benefits. Like, it would be a lot easier to get into space.
Because we wouldn't need as much fuel to escape Earth's gravity.
Right. Space travel would become much cheaper and easier.
Space tourism for everyone.
Maybe one day. But it wouldn't all be easy. Walking on ice would be super dangerous, and strong winds could actually knock you over.
Okay, so there would be trade-offs.
Always. And the transcript even gets into how life on Earth might evolve differently with weaker gravity.
Oh, that's right. It talked about animals getting much bigger.
Yeah, like imagine tigers the size of trucks.
Or, like, giant cockroaches.
Yeah, those two.
Yeah.
And birds could have huge wingspans.
I'm not sure about the giant cockroaches, but the rest of it sounds kind of cool.
Right. It would be a very different world. And we humans, we might end up being taller and thinner with weaker bones because we wouldn't need as much support.
We'd be like supermodels of the future.
Maybe. And even our everyday objects would change. Everything would be lighter and more delicate.
So a low-gravity Earth would be pretty wild. But let's go to the other extreme now. What if gravity doubled?
Okay, now that would be a problem. The Brightside source talks about how airplanes just wouldn't be able to fly
Why not?
because they rely on lift to overcome gravity. If gravity doubled, their wings just wouldn't be able to generate enough lift.
So no more flying.
Not unless we completely redesign airplanes.
And what about us? Like, what would it feel like to live in a world with double gravity?
Everything would feel incredibly heavy. We'd be constantly exhausted just from trying to move around.
Just walking around would be like lifting weights.
Basically, yeah. And our spines would be under so much pressure that we'd probably end up walking on all fours just to stay balanced.
Walking on all fours. Like we devolve.
Kind of, yeah. It would be the most efficient way to get around. And our bones would have to get much thicker just to support our weight.
Ouch. So, not exactly a comfortable existence. What about buildings and stuff?
Most buildings would probably collapse. Bridges, too. They're just not designed to withstand that much force.
A world of rubble.
Pretty much. And even rain and snow would be dangerous. They'd fall with twice the force, so it would be like getting pelted with hailstones all the time.
So going outside would be risky.
Yeah, not a good idea. And the source even talks about how our food supply would be affected.
How so?
Well, some plants might not be able to survive with double gravity. They wouldn't be able to transport water and nutrients effectively.
Like they just starve.
Basically, yeah. And other plants might actually thrive, but it would change the balance of our ecosystem.
So we might end up eating a lot of, like, carrots or something.
Yeah, the source actually mentions that people might develop orange skin from eating so many carrots.
That's a strange side effect. But what about Earth itself? Would it be affected by double gravity?
Definitely. It would probably move closer to the sun, which would make the planet much hotter.
Oh, great. So we're talking about a scorching, high-gravity world.
Yeah, not a very pleasant place to live. And the moon would get closer too, which would mess with the tides.
So we'd have super high tides.
Yeah, and much more frequent earthquakes and volcanic eruptions. Basically, Earth would become a lot more volatile.
Sounds like a pretty rough place to live.
Yeah.
But what about animals? Would they be able to adapt?
Well, they'd have to. Puppies would probably grow much slower because it would be so hard for them to move around.
Oh, that's sad.
Yeah. Insects might develop stronger legs just to be able to walk. And big predators would have a tough time hunting.
Because they'd be too slow and clumsy.
Exactly. It would be a huge challenge for them. And even trees would have to adapt.
How would trees change?
Well, they'd probably be much shorter and thicker. Their branches would have to be really strong to support the extra weight.
So it would be a world of, like, bonsai trees everywhere.
Kind of, yeah. It would definitely be a strange sight.
But humans are pretty clever. Maybe we could invent some cool technology to help us deal with double gravity.
Yeah, the source talks about some possibilities, like we might build airplanes that fly much higher, where gravity is weaker.
But we'd have to go even higher than we do now.
Right. And maybe planes would have horizontal seating so that passengers wouldn't be crushed by the G-forces.
Interesting.
And we might start using exoskeletons to help us move around.
Like those robotic suits that you see in movies?
Yeah, something like that. They would provide the extra support we'd need. And we might even develop anti-gravity treadmills.
Anti-gravity treadmills. What would those be like?
Well, they basically create a low-gravity environment so that we could exercise without putting so much strain on our bodies.
That's pretty cool. And maybe we'd even figure out how to adjust gravity for weightlifting.
So you could choose how heavy you wanted the weights to feel.
Exactly.
That would be awesome.
Yeah, it would make working out a lot more customizable.
But what about our bodies themselves? Would we evolve to handle double gravity?
The source suggests that our skin might get thinner and heal slower because it would be under so much pressure. We might even start using fish skin for bandages.
Fish skin. That's a weird thought.
Yeah, it's a bit strange. But apparently, fish skin is really good at healing under pressure. And over many generations, we might actually adapt to handle higher gravity. We might not even need all those technological crutches.
So it's not necessarily game over for humanity.
No, we're pretty adaptable.
Yeah.
And who knows, maybe we'd even start colonizing other planets with different gravity. Like Kepler 452b has a much stronger gravity than Earth, so we could get used to higher gravity there. And then we could visit Mars or the Moon to experience lower gravity.
Exactly. It would be like a cosmic vacation.
I like the way you think. So we've talked about what would happen if gravity disappeared, if it got weaker, and if it got stronger. But did you ever imagine there'd be so much variation in gravity just within our solar system?
To be honest, no. But the source you sent me actually lays out this scenario where you walk into a room and experience the gravity of different planets. It's a really cool thought experiment.
Yeah, it's like a gravity simulator. So what would it feel like?
Okay, imagine walking into the Mercury room. Gravity there is a bit weaker than Earth, so you'd feel a little lighter, but not drastically different.
Okay, so not too crazy.
Right. Then you step into the Venus room, it feels pretty much the same as Earth.
Okay, Venus is our twin, in a way.
Kind of, yeah. But then, get this. You walk into the Moon room, and boom.
What happens?
You can suddenly jump like 9 feet in the air. It's like having superpowers.
I'd be doing slam dunks all day long.
Yeah, it would be awesome. Then you head to the Mars room. It feels pretty similar to Mercury, a bit lighter than Earth.
Gotcha. So those are the rocky planets. What about the gas giants?
Well, the gas giants are a completely different story. You couldn't actually walk into a Jupiter room because there's no solid surface.
Right, it's just gas all the way down.
Exactly. And Jupiter's gravity is way stronger than Earth's. It would crush you.
Okay, so we'll skip the Jupiter room.
Definitely. Saturn is similar massive gravity and no solid ground.
Gotcha. What about the ice giants Uranus and Neptune?
Uranus has a bit weaker gravity than Earth, so you'd feel lighter there. Neptune, on the other hand, has slightly stronger gravity.
So it's amazing to think that there's this whole range of gravitational forces right here in our cosmic neighborhood.
Yeah, it really puts things in perspective.
And it makes you realize that the gravity we experience here on Earth is kind of special.
It's definitely our Goldilocks zone. But all of this talk about gravity, it makes you wonder, like, how does it actually work? What is this mysterious force that's shaping the entire universe?
Right. It's invisible, it acts over vast distances, and it even affects time itself. It's mind-blowing.
It really is. But luckily, we've got some really smart people who've spent centuries trying to figure it out. And one of the most important names in the history of gravity is Isaac Newton.
Oh yeah, Newton. The apple guy.
Exactly. He's the one who came up with the law of universal gravitation, which basically says that every object in the universe attracts every other object with a force that depends on their mass and the distance between them.
So the bigger and closer things are, the stronger the attraction?
Precisely. And that was a huge breakthrough. It explained why the planets orbit the sun, why the moon orbits the Earth, and even why things fall down when we drop them.
It's the foundation of our understanding of gravity. But then along came Einstein and kind of turned everything upside down.
Yeah, Einstein's theory of general relativity was a game changer. It presented a completely new way of thinking about gravity.
So what's the difference between Newton's idea and Einstein's?
Well, Newton saw gravity as a force that acts at a distance. But Einstein said that gravity isn't a force at all. It's actually a warping of space-time.
Wait, a warping of what?
Space-time. It's like the fabric of the universe. It's made up of space and time woven together. And Einstein said that massive objects actually bend and distort this fabric.
Okay, I'm trying to picture this.
Imagine a bowling ball on a trampoline. It creates a dip, right?
Yeah, I get that.
Now imagine rolling a marble across the trampoline. Instead of going in a straight line, it would curve towards the bowling ball because of the dip.
Oh, I see. So it's not that the bowling ball is pulling on the marble, it's that the marble is following the curve of the trampoline.
Exactly. And that's kind of how gravity works according to Einstein. Massive objects like planets and stars create these warps in space-time, and other objects just follow those curves.
So gravity is like a cosmic trampoline.
Yeah. Kind of, yeah. It's a simplified analogy, but it helps to visualize how gravity works.
It's a really trippy concept. But it explains a lot of things that Newton's theory couldn't, right?
That's right. Like, it explains why light bends around massive objects. That's something that was observed but couldn't be explained by Newton's theory.
So Einstein's theory is the best explanation we have for gravity right now.
It's the best we've got. But there are still a lot of mysteries about gravity that we don't fully understand.
Like what?
Well, for one thing, gravity is incredibly weak compared to the other fundamental forces of nature.
You mean like electromagnetism and the strong and weak nuclear forces?
Right. Those forces are way, way stronger than gravity, like trillions of times stronger.
That's crazy. Why is gravity so weak?
That's one of the big questions. We don't really know, but it's possible that gravity is actually an emergent force.
An emergent force, what does that mean?
It means that gravity might not be a fundamental force itself, but rather a result of the interactions between more fundamental things. Kind of like how temperature emerges from the movement of molecules.
Oh, I see. So gravity is like a side effect of something else going on.
Possibly, but we don't really know what that something else is. And then there's the whole question of gravitons.
Gravitons?
Yeah, they're hypothetical particles that are thought to carry the force of gravity, like how photons carry the electromagnetic force.
So if we could find gravitons, we'd understand gravity better.
It would be a huge step forward, but so far no one has been able to detect them.
So gravity is still this elusive force that we're trying to unravel.
Absolutely. It's one of the biggest mysteries in physics, and it's especially challenging to understand how gravity works at the quantum level, like inside black holes and at the very beginning of the universe.
So we've got a lot more to learn, but we're making progress, right? Like we've been able to observe some pretty cool things that prove Einstein's theory.
Oh yeah, definitely. One of the most stunning examples is gravitational lensing.
Gravitational lensing, what's that?
So imagine a really massive object, like a galaxy cluster. Its gravity is so strong that it actually bends the path of light that passes by it.
So it's like a cosmic magnifying glass.
Exactly. And that means that we can see objects that are behind the galaxy cluster, even though they should be hidden from view. Their light gets bent around the cluster and reaches us.
It's like a cosmic trick of the light.
It is. And it's a really powerful confirmation of Einstein's theory because it shows that gravity really does warp space-time.
Pretty amazing. And then there are gravitational waves, right?
Oh yeah, gravitational waves are another huge discovery. They're literally ripples in the fabric of space-time that are caused by some of the most violent events in the universe.
Like what?
Like the collision of black holes or neutron stars.
So these massive objects collide, and it creates these waves that travel through the universe.
Exactly. And those waves can travel for billions of years and still be detected here on Earth.
So how do we detect them?
We use incredibly sensitive instruments called interferometers. They're basically giant L-shaped detectors that can measure tiny changes in the distance between mirrors.
So a gravitational wave passes by, and it causes the mirrors to move slightly.
That's right. And by measuring those movements, we can actually reconstruct the gravitational wave signal and learn about the event that created it.
It's like we're listening to the universe.
It is. It's a whole new way of observing the cosmos, and it's giving us incredible insights into some of the most extreme phenomena in existence.
So gravity is this fundamental force that shapes the universe, and we're still learning so much about it. But the source you sent me also talks about some places here on Earth where gravity seems to behave a little strangely.
Oh, yeah, those are really interesting. Like, there are these places called gravity hills where things seem to roll uphill.
Really? Like defying gravity.
It seems that way. But usually it's just an optical illusion.
What do you mean?
Well, the landscape can trick your eyes into thinking that something is uphill when it's actually downhill.
So it's just a matter of perspective.
Right. But there are some places where the explanation isn't as clear cut, like the crooked forest in Poland.
Oh yeah, I've seen pictures of that. It's really weird.
Yeah, it's a grove of pine trees that are all bent near the base.
And no one knows why.
There are a lot of theories. Some people think it was done intentionally by humans, maybe to create curved wood for furniture or something.
That's an interesting idea.
Yeah, but no one really knows for sure. And then there's the whole question of whether it could be caused by some kind of localized gravitational anomaly.
So maybe gravity is actually different in that specific spot.
It's possible, but it's a very difficult thing to measure, and there's no definitive evidence for it.
So it remains a mystery.
For now, yeah. But it's those kinds of mysteries that keep us exploring and asking questions.
Absolutely. And then there were those waterfalls that seemed to flow uphill.
Oh, yeah, those are cool. But usually that's just because of strong winds pushing the water upwards.
So gravity isn't actually being defied.
No, it's just being overcome by another force.
Makes sense. And I remember reading about a road in Korea where things really do roll uphill.
The dope road, right?
Yeah, that's the one. And apparently it's not just an optical illusion.
The source says it's a genuine phenomenon.
So what's the explanation?
No one knows for sure, but it's definitely a place that makes you question your assumptions about how gravity works.
It's like gravity's taking a break there.
Maybe. And then there are those balancing rocks, like the Golden Rock in Myanmar.
Oh yeah, the one that looks like it's about to fall off the cliff.
That's the one. It's a huge boulder that's precariously perched on the edge of a cliff, and it's been there for centuries.
So how is it even possible?
Well, local legend says that it's held in place by a sacred hair of Buddha.
A hair? That's a pretty strong hair.
Yeah, it's a miracle. But the scientific explanation is probably more to do with the specific shape of the rock and its center of gravity.
It's just perfectly balanced.
It seems that way. But it's still amazing to think about how something so massive can stay balanced like that for so long.
It's a reminder of the incredible forces at play in nature.
Right. And then there are those places that are specifically designed to play with our perceptions of gravity, like the Oregon Vortex.
What's that?
It's basically a tourist attraction where things seem to defy gravity. But it's all done with clever illusions.
So it's like a fun house for your sense of balance.
Exactly. And it's a good reminder that our perception of gravity isn't always reliable.
Sometimes our eyes can deceive us. But there are also some real, measurable variations in gravity across the Earth, right?
That's right. Like there's the Hudson Bay anomaly in Canada.
What's that?
It's a region where gravity is slightly weaker than it should be.
Why is that?
Well, scientists think it's because of the massive ice sheet that covered that area thousands of years ago.
So the ice actually changed the Earth's gravity.
It did. It compressed the Earth's crust, and that effect is still lingering today.
That's pretty incredible. So gravity isn't just this constant force. It can actually be affected by things that happen on Earth.
Exactly. It's a dynamic force that's constantly interacting with the environment.
So we've covered a lot of ground today, from the theoretical to the downright strange. But there's one more topic I want to touch on. Anti-gravity.
Anti-gravity, like defying gravity completely.
Yeah, it's a staple of science fiction.
Right.
Flying cars, levitating objects, that kind of stuff.
Yeah, it's definitely a cool concept. But is it actually possible?
That's the million-dollar question.
Yeah.
And the source you sent me talks about the difference between zero gravity and true anti-gravity.
Right. Zero gravity is what astronauts experience in space. They're basically in free fall, so they don't feel the effects of gravity.
But that's not the same as actually repelling gravity, right?
No, it's not. True anti-gravity would mean creating a force that actively pushes against gravity.
And is that something we can actually do?
That's where things get a bit speculative. There are some theoretical ideas out there, like modified theories of general relativity.
What do those theories say?
Well, they suggest that there might be extra dimensions of space or new fundamental forces that we haven't discovered yet. And those forces might interact with gravity in a way that could create a repulsive effect.
So it's like bending the rules of gravity.
Kind of, yeah.
Yeah.
But it's all very hypothetical. And then there's dark energy.
Dark energy, the stuff that's making the universe expand faster.
Exactly. Dark energy has a repulsive effect, but we don't really understand it very well. And it's not clear if we could ever harness it for our own purposes.
So manipulating dark energy is probably not on the cards anytime soon.
Probably not. And then there are even more out there theories, like superstring theory.
Superstring theory. That's the one where everything is made of tiny vibrating strings, right?
Yeah, that's the one. And it has some really interesting implications for gravity. It suggests that gravity might be a result of these strings interacting in higher dimensions.
So gravity is like a symphony of strings.
Kind of, yeah. But superstring theory is incredibly complex, and we're still a long way from fully understanding it.
So anti-gravity is still very much in the realm of science fiction.
For now, yeah. And there are a lot of skeptics who think it might be fundamentally impossible.
Why is that?
Well, one of the big problems is that anti-gravity seems to violate the law of conservation of energy.
Which says that energy can't be created or destroyed.
Right. And if you could create a force that repels gravity, you'd essentially be creating energy out of nothing.
So it's a bit of a physics no-no.
It seems that way. But who knows, maybe one day we'll find a way around it.
If we did, it would completely revolutionize our world.
Oh yeah, it would be game-changing. Imagine flying cars, space travel without rockets, all sorts of incredible possibilities.
It's a tantalizing thought. But for now, we'll have to stick to our gravity-bound existence.
At least for now. But it's always good to keep dreaming and exploring the possibilities.
Absolutely. So we've journeyed from the smallest atoms to the largest stars, exploring the profound influence of gravity on every scale.
We've seen how gravity can be a destructive force, a creative force, and even a source of wonder and mystery.
And it's a reminder that this fundamental force that we often take for granted is one of the most essential ingredients in the recipe of the universe.
It's the glue that holds everything together. And without it, well, things would get pretty messy.
To say the least.
Mm.
So for all of you listening out there, take a moment to appreciate the pull of gravity. It's keeping your feet on the ground, the Earth in orbit, and the stars shining bright.
And maybe, just maybe, someday we'll unlock its secrets and learn how to control it. But until then, keep your curiosity alive and explore the wonders of the universe.